The topic is thought, consciousness, and memory, the physiological basis of thought, consciousness, and memory. This is for the freshers in MBBS of Sri Lakshmi Narayana Institute of Medical Sciences, Puducherry, affiliated under Bharat Institute of Higher Education and Research. The course name is Physiology, and it is from the second half of physiology. The central nervous system, the topic, I repeat, is thought, consciousness, and memory. The presenter is Dr. Henry Bharadwaj, MD, Professor, Department of Physiology, Faculty of Medicine, Sri Lakshmi Narayana Institute of Medical Sciences, Puducherry, affiliated under Bharat Institute of Higher Education and Research, Chennai. Holistic theory of thought, holistic, it's complete. It is till what we know till now, holistic. It holds up. So that means it is given in a nutshell. We don't know much about it. We ought to know more. Cerebral cortex destruction. Destruction of the cerebral cortex reduces depth of thought and degree of awareness of surroundings. That means the person is superficial of thinking, and the degree of awareness of surroundings is less. Simultaneously, the signals arise from the cerebral cortex, thalamus, limbic system, and reticular formation. The last three, the thalamus, limbic system, and reticular formation, are involved with pleasure, displeasure, pain, or comfort. Cerebral cortex, localization in skin. When the cerebral cortex is involved, there is localization in the skin. When the cerebral cortex responds, which is due to localization in the skin and field of vision. Only these two places. Excruciating pain. The structures involved is hypothalamus, amygdala, and stimulation of mesencephalon. Hypothalamic stimulation, amygdala stimulation, and mesencephalonic stimulation causes excruciating pain. Thoughts result in pattern of stimulation. Thought where? In the cerebral cortex, in the thalamus, limbic system, and reticular formation. Also, in the hypothalamus, amygdala, and mesencephalon, thought results in pattern of stimulation. Consciousness, a continuous stream of awareness of surrounding and sequential thoughts. Consciousness is defined as the continuous stream of awareness of surroundings and sequential thoughts. So it's not only awareness of the surroundings, it's also awareness of the sequential thoughts that occur in waves in a mind life. Memory, habituation. Habituation is when nerve tissue is stimulated. After a while, it stops responding. This is called habituation. Memory sensitization, pain or pleasure, there occurs facilitation of synaptic pathway. There is a facilitation of synaptic pathway. Memory sensitization, pain or pleasure. What occurs is a facilitation of synaptic pathway. Basal limbic region sees important from unimportant. Basic limbic is responsible for emotions, and it sees important from unimportant matter. Memory, to store or suppress basal limbic region is important, and when there is a need to store or suppress memory, basal limbic system, basal limbic region is involved. Classification of memory. Thoughts, that was a thought. It comes with memory. Time duration, short-term memory, intermediate, long-term memory, and long-term memory. So memory can be based on time duration, short-term memory, intermediate long-term memory, and long-term memory. Type of variety in memory. Details of thought, declarative memory. Thought is involved in memory. That is, the person is able to think and retrieve from memory and is able to verbalize. Skill memory is memory that doesn't come to the consciousness. It's reflexive memory. It's not a term for skill memory. Reflexive memory. Short-term memory. What happens actually in short-term memory? What is the basis? There is a circuit of reverberating neurons. Circuit of reverberating neurons, like it occurs in the classical withdrawal reflex, where the spinal animal, when stimulated in the skin, there's up and down reverberation of impulses, and that circuit of reverberating neurons, the neurons are involved in a reverberating fashion, and it is a circuit. Short-term memory. What are the classical things? Short-term memory is a facilitator terminal and a sensory terminal that has come from short-term memory. A sensory terminal comes from the frontal lobe, and it goes to there is a facilitator terminal, and this produces cyclic AMP as a second messenger, and it opens up calcium channels, and calcium ions enter to cause fusion exocytosis of serotonin, and memory system that has been discovered in the snail Aplysia. Cyclic AMP is cyclic adenosine monophosphate. So second messenger, calcium ions are involved, and the neurotransmitter is serotonin. Intermediate long-term memory, chemical changes in the presynaptic terminal, physical changes in the postsynaptic neuronal membrane, or both. Chemical changes in presynaptic terminal and physical changes postsynaptic neuronal membrane, or both. Memory lasts up to 3 weeks in amnesia. We have noted this. We have observed it, that memory lasts up to 3 weeks in aplysia. Yeah, this is intermediate and transient long-term memory. Intermediate long-term memory and transient long-term memory. The sensory terminal, this is the sensory terminal, and as it was pointed out earlier, the facilitator terminal, and it gives out serotonin, and serotonin leads to production of cyclic AMP, and calcium ions come in. So calcium ions, more calcium ions come in, and more calcium ions determine the long-term memory. And what do the calcium ions do? They take part in fusion exocytosis process and release neurotransmitters which act on the postsynaptic neuron. Structural changes. Now, the very important point is that the drugs which block protein synthesis can influence memory, can cause poor memory. Protein synthesis blocked by drugs can cause reduced memory storage. Structural and the other structural changes include increased active zones. These active zones have got a lot of vesicles that contain neurotransmitter. So the vesicles are increased neurotransmitter vesicles. So active zones are such a increase wherein neurotransmitter vesicles are also increased. These active zones are under the presynaptic neuron and increase in presynaptic terminals. Presynaptic terminals. So this is a structural change and change in dendritic spine structure. The dendritic spine, the most common of there are three synapses: axodendritic, axosomatic, and axoaxontic. Axodendritic is the most common, and it is accentuated in memory processes. Consolidation of memory traces. 5 to 10 minutes for minimal consolidation. That's being discovered. 1 hour and more for stronger consolidation. RNA, protein, and RNA synthesis, and RNA is involved, and protein synthesis is involved in consolidation of memory traces. The hippocampus, important output, the hippocampi, two hippocampi, one left and one right. The important output pathway for pain and pleasure, the hippocampi, one on each side. Removal of hippocampi and epilepsy, anterograde causes anterograde amnesia. That is, once the hippocampi are removed, the memory that occur, the events that occur after the removal of the hippocampi can cause are lost. This is called anterograde amnesia. Lesion of hippocampus. Both, if there's a lesion in the hippocampus, both anterograde and retrograde amnesia are lost. Anterograde is from the moment the lesion has occurred, there's poor memory storage. And retrograde amnesia means that after the lesion develops, there is a loss in older memory forms that have already got consolidated, but they lose, they are lost. So this is retrograde. Nil memory access with hippocampi. There is nil memory access. Thalamic lesion, search and read out memory loss. Thalamic. Search and read out memory loss. Search means search in the mind of what is being stored as memory is lost. And read out memory, the ability to read, when you are reading the memory that occurs is lost. Retrograde amnesia. Thalamic lesion, you get retrograde amnesia. That is amnesia after a lesion. The retrograde amnesia is loss of memory after the lesion. All that is formed and consolidated, memory that is formed and consolidated is lost after the lesion, not involved in reflexive skill memory. So the hippocampi are not involved in reflexive skill memory. So there's another basis for reflexive skill memory. A quick brush up. So it's only a theory of thought. It's still more to do. There are a lot of gaps, and destruction of the cerebral cortex causes reduces depth of thought and degree of awareness of the surroundings. Simultaneous signals, cerebral cortex, thalamus, limbic system, reticular formation. There are, when there is a thought, there are signals in the cerebral cortex, thalamus, limbic system, and reticular formation. Last three, pleasure, displeasure, the last three, there is thalamus, limbic system, and reticular formation. The last three are lost: pleasure, displeasure, pain, or comfort. Cerebral cortex, localization in skin and field of vision. So it's cerebral cortex. Whenever there is a localization in the skin and the field of vision, these two things are create an impression, and they can lead to thought, thought processes. Hypothalamus, amygdala, and mesencephalon stimulation causes excruciating pain. Thought results in pattern of stimulation. If there's a pattern of stimulation, it results in thought process. Consciousness, continuous stream of awareness of the surroundings and sequential thoughts. Continuous stream of awareness of surroundings and sequential thoughts. That means it's not only a continuous stream of awareness of surroundings, it's also continuous stream of awareness of sequential thoughts that come, one after the other in sequence. Memory, habituation. Habituation is loss of response to a continued stimulus. And here, extinction takes place, extinction. So initially there is a response, and later there is a loss of response, there's an extinction. The molecular basis here is both the ion calcium and the neurotransmitter. And more so the calcium ion. The loss of calcium ion entry into the presynaptic duct and release of neurotransmitter into the interstitial fluid. Memory sensitization, pain or pleasure. Pain can bring about memory sensitization, and pleasure can also bring about memory sensitization. What do you mean by memory sensitization? That is one memory causing induction of another memory. Facilitation of synaptic pathway occurs in pain or pleasure, where memory sensitization occurs. Basal limbic regions seems important from unimportant. The basal limbic region, it filters important from unimportant. Memory to store or to suppress, and this is brought about by basic limbal region. Classification of memory, time duration. You have short-term memory, you have intermediate, long-term memory, and you have long-term memory. Type of variety, details of thought, declarative memory, skilled memory, yes, reflexive memory, which doesn't come up to the cerebral cortex. Short-term memory involves circuit of reverberating neurons, wherein there is working memories involved to perform throughout during the day. What we need is to perform What we need is to, uh, when we perform a series of actions to bring about an achievement, we tend to, uh, we need a working memory, and this is short-term memory. We lose it immediately. Very soon we lose it. It's a circuit of reverberating neurons that perform this uh, working memory. Short-term memory, there is the recycles are involved and the facilitator terminal, which is the facilitator terminal, and serotonin is released. Serotonin brings about cyclic AMP and calcium channels. They open up calcium channels and calcium ions are involved in this release of neurotransmitter in the sensory terminal. Sensory stimulus. What is the sensory stimulus? Is the, uh, anything like visual input or hearing input, auditory input or visual input or thought process. They are all sensory. They can all lead to short-term calcium ion is increased in the presynaptic to bring about fusion exocytosis. And neurotransmitter is released into the interstitial fluid to act on the postsynaptic neuron, whereby ions enter the postsynaptic neuron. It's mostly stimulatory in short-term memory, and the ion mostly involved is sodium and uh, neurotransmitters glutamate. Glutamate is a stimulating neurotransmitter. Intermediate long-term memory, chemical changes in the presynaptic terminal. What could be the chemical changes in the presynaptic terminal? There is an increase in calcium ion, or there could be more cycles in the presynaptic top cycles containing neurotransmitters. Physical changes, postsynaptic neuronal membrane. There are changes in the postsynaptic neuronal membrane, the long-term memory. The channels increase, the cationic channels increase, and these channels cause entry of cation, which causes depolarization in the postsynaptic neuron. And both chemical change, that is, and physical change, that is presynaptic terminal, there can be calcium neurotransmitter increase, or there can be in the postsynaptic neuron, there can be channel increase, or both. Memory lasts up to 3 weeks in a patient. Intermediate long-term memory lasts up to 3 weeks. Intermediate long-term memory and transient long-term memory. What happens here is that, again, there is a stimulus, there is a facilitator terminal, serotonin is released, this increases cyclic AMP and it opens calcium channel, and calcium ions come into the presynaptic stuff towards the cleft, synaptic cleft, and the sensory terminal, sensory stimulus could either be visual, auditory, or process, which causes neurotransmitter synthesis and thanks to the calcium ions and blocking calcium channels by ligand calcium channels by the ligand cyclic memory system that has been discovered in the memory system that has been snail amnesia, like it can monophosphate. Structural changes. One important point that drugs, protein synthesis can be blocked by drugs, and this can hamper memory. One, increase active zones. That means in the dendrites there are active zones which have a lot of neurotransmitter. So the postsynaptic neurotransmitter is quite a lot, and it just needs the presynaptic or the axonodendritic synapse here, which causes movement of the neurotransmitter from the dendrite to the axon. Increased neurotransmitter recycle. This is another change apart from protein synthesis blocked by drugs, which could hamper memory. One, increase active zones and increase memory, increase neurotransmitter recycles. This is protein synthesis occurs. There is a reinforcement, and the neurotransmitter recycle is increasing. Increase in presynaptic terminals. As such, the presynaptic terminals can increase and can bring about enhancement of memory. So when a process is repeated again and again, then there can be changes and increase in presynaptic terminals. Change in dendritic spine structure. The dendritic change in dendritic spine structure. This can cause a lot of dense zones in the dendritic spine, dense areas, in the dense spots in the dendritic spine, which have a lot of postsynaptic neurotransmitter. Consolidation of memory traces. 5 to 10 minutes for minimal consolidation. Why does it happen? It happens in the hippocampus. So short-term memory traces are made into long-term memory traces, and it occurs in found that 5 to 10 minutes for minimal consolidation, and 1 hour and more for stronger consolidation, wherein ribose nucleic acid is involved and protein synthesis is involved. If the memory trace where the memory lasts longer, or if it is being reverberated in the neurons more than an hour, there is stronger consolidation, RNA and protein synthesis, RNA, ribose nucleic acid and protein synthesis. They bring about protein synthesis. Now, the hippocampi play a very important role in consolidation of memory traces. Important output pathway for pain and pleasure. So the pain and pleasure drive the hippocampus to it will find out if a particular stimulus is worthwhile or is meant to be not accepted as important. Removal of hippocampi in epilepsy, anterograde amnesia. Removal of hippocampi in epilepsy. There is hippocampus. There can be epilepsy due to hippocampi involvement. There are 2 hippocampi, the right and the left hippocampi. The right and the left hippocampi. The right and the left hippocampi. Lesion of hippocampi, both anterograde and retrograde amnesia, nil memory access. Thalamic lesion, search and read out memory lost, retrograde amnesia. What is anterior brain means after there is a lesion of the hippocampus, the memory, the events that occur after the lesion of the hippocampus don't get consolidated as memory traces. But thalamic lesion, search and read out memory is lost. Searching in the mind through words is lost. Read out memory is lost. The ability to read out and remember is lost. And retrograde amnesia takes place after the lesion. Before the lesion, what all events have occurred are wiped out from the memory. And hippocampi, uh, it's a definite mention that the hippocampi are not involved in reflexive skill memory. Thank you.